Good evening, guys. In today's video, Thursday, March 19th, we're going to go over the homework problems from yesterday, page 410. And it's going to be 23 through 32, but I divided them into three parts. If we start with number 23, we can see tan of pi over 2 minus x. And right away, we can link that to a cotan of x. I put right here the personalized identity sheet, and you can see that tan of pi over 2 minus theta or minus x equals cotan of theta or cotan of x. So this is the identity I have used. And cosecant over cosecant squared is just cosecant. We gave the example yesterday of t divided by t squared is just t on the bottom, so 1 over t. And this is what happened here. You can rewrite the cotan as cosine over sine, and the cosecant as 1 over sine. Keep change flip since we're dividing fractions. Single fraction divided by single fraction. Cosine over sine multiplied by sine over 1. The cosine cancel out, and the sine cancel out, and you're left with cosine. I got a couple questions on Remind. Whether you simplify in a different way but get the same answer, is that fine? Of course, it's totally fine. It's never my way or nothing. And that's the cool thing about simplifying. You could do it in different ways and still get as long as you get the same simplest form, I'm okay with that. And it's up to you guys how you want to do it. This is the way I found maybe the shortest, maybe the most obvious, but of course, feel free to use a different way. 1 plus tan. Now, this, I want to talk about this because this is very common misconception. This is not 1 plus tan squared. So you can't say it's secant, and you might question, why didn't I put that as secant? I want to go back to the identity sheet, and I want to show you guys right here. It's 1 plus tan squared equals secant squared. It's not secant equals 1 plus tan, and it's not the same thing because 1 plus tan is not the same thing as 1 plus tan all squared. So this is what I'm talking about. 1 plus tan, 1 plus tan squared. This is not this parentheses squared. No, that's not true because it follows the special case. This is 1 plus 2 tan plus tan squared. So it's not 1 plus tan squared. So you can't say, oh, I see 1 plus tan, that is secant, because I know that 1 plus tan squared equals secant squared. This is not true. So the identity is only for the squared ones. So let's go back to the problem, which is number 24. 1 plus tan, I can't do anything about it yet. And I rewrite the cotan as 1 over tan. I can make a common denominator, so multiply by tan on top and the bottom. And I get 1 plus tan on top and tan plus 1 over tan. I also got a question on Remind. I missed in one of the steps, like I wrote cosine without cosine x. That's just for simplifying, but of course, every trig function has an input. So if I say tan, obviously you guys know it's tan of x. So now keep change flip at this step. 1 plus tan multiplied by tan over 1 plus tan. Those cancel out and you're left with tan. Number 25. Secant squared plus cosecant squared. And the first thing that came to my mind is 1 plus tan squared and 1 plus cotan squared. And those are... I want to make sure I keep going back and forth at the beginning just so you guys can get used to this sheet. So 1 plus tan squared should remind me of secant squared. And if I have secant squared, that should remind me of 1 plus tan squared. And cosecant squared should remind me of 1 plus cotan squared and vice versa. So if you look at number 25, secant squared reminded me of 1 plus tan squared. Cosecant squared reminded me of 1 plus cotan squared. And I just distributed the negative. So now tan squared minus tan squared cancel out. Cotan squared minus cotan squared canceled out. 1 plus 1 equals 2. For number 26, I did the same thing. Secant squared is 1 plus tan squared. So I substituted it. And minus tan squared, I just copied it down. Cosine squared plus sine squared equals 1 as long as I have the same angle. And I do. I have V and V, same input. So that makes it a 1. Tan squared and tan squared cancel out. 1 over 1 is 1. And this was the first set. Now, the second set. Sine, parentheses, tan plus cotan. So you distribute sine multiplied by tan plus sine multiplied by cotan. The tan is sine over cosine. The cotan is cosine over sine. So now you get sine multiplied by sine, which is sine squared. Just a reminder, x and x does not make an x squared. It's still the input of the function. You're not multiplying the x's, you're multiplying the sines. Divided by cosine plus sine and sine cancel out. You're left with cosine. You want to add a fraction and a trig function, you need a common denominator. So I multiply by cosine on top and cosine on the bottom. I got sine squared plus cosine squared and over cosine. And those two, according to identity 9, Pythagorean identity, that's a 1 over cosine, which is secant. Number 28, sine minus tan, which is sine over cosine, and multiply by cosine. The cosines cancel out. And cosine of pi over 2 minus theta is equal to sine of theta. This is one of the cofunctions identity. So now sine minus sine cancel out, plus sine, so you're left with sine. Number 29. It looks a little messy, but if you just substitute, anytime you see tan, secant, cotan, so not we call them we call basic trig functions and the non-basic one, if you want. The basic one, the building blocks are the sine and cosine, and everything else comes from or is built from sine and cosine. So sine multiplied by cosine and multiplied by, instead of tan, I put sine over cosine. Instead of secant, I put 1 over cosine. And if instead of cosecant, I put 1 over sine. And it's multiplication, which is nice. And that's what's going to allow me to simplify across. Cosine and cosine gone. Sine and sine are gone. So I'm left with sine on top, multiplied by 1, 1. So sine, and divided by cosine, which is tan. I'm sure this one you could have done it in a different way, and I'm more than happy to look at your own methods if you want to text me and remind. Number 30. Number 30 shows a special case, which is a minus b, a plus b. As you guys see, I put it to the side, which equals a squared minus b squared. The a and b aren't as easy here because they are trig functions. So it's secant y, which is the a, and tan y, which is the b. So the distributed form would be secant squared of y minus tan squared of y. And I repeat it again and again. Secant y multiplied by secant y is secant squared of y. The input does not change. And the denominator remains the same. This should remind me of an identity which equals to 1. I'm going to go back to this. It's linked to this one. Secant squared equals 1 plus tan squared. So, sorry, it turned a little bit blurry. So if you subtract tan squared on each side, secant squared minus tan squared equals 1. Okay, so that's what I have used here. Secant squared minus tan squared equals 1. And secant is 1 over cosine. Keep, change, flip. So 1 multiplied by cosine over 1 gives you just a cosine. Okay, and last set for today. It has only 2 problems. So tan divided by cosecant squared, that's a 1 over sine squared. And tan over secant, which is 1 over cosine squared. Now, keep, change, flip. And I put sine over cosine because that's the tan. multiplied by sine squared over 1, and plus tan again, so sine over cosine multiplied by the flip of this. So now you can see sine multiplied by sine squared plus sine multiplied by cosine squared, and all over the common denominator. We don't multiply these. Again, yesterday I reminded you of the rule to add fractions using a common denominator. If you guys have like a 2/5 and a 7/5, that makes a 9/5. It does not make a 9/10. So you don't add the denominator. The denominator is a common denominator. So that's why we leave it as cosine. Now you can see on top something that you might like, but not yet. Sine squared plus cosine squared, but there's a barrier or there's something that's blocking it. So that's why I'm going to use sine x as a common factor. So I factored out sine x. Parentheses, this is what's left from the first term, and this is what's left from the second term, and separated by an addition. And that's what's nice because it's equal to 1. So sine over cosine equals tan. And this whole mass turns into a tan x. 32, which is the last one, looks a lot messy. It's very similar to the previous one, except that the top is not simply like a tan x. And also you could have done that in a different way. Again, you're more than welcome to actually share with me a different way that is shorter than mine. But this is the one that came to my mind. So anyways, let's see how I did that. So secant is 1 over cosine. Since it's squared, it's squared. Cosecant 1 over sine. It's not squared. Secant squared is 1 over cosine squared. Cosecant squared 1 over sine squared. You're adding two fractions. You need a common denominator. You're going to multiply this by the second and this by the first. That's what I did here. When you multiply the bottom, you have to multiply the top. So sine 1 over cosine squared multiplied by sine, that's the top. And on the bottom, you get sine squared plus cosine squared. Because sine squared, you guys can see here, I just put it in different color to kind of emphasize on it, because we multiplied the cosine squared by sine squared. And the sine squared by cosine squared. So we'll turn into sine squared plus cosine squared over sine squared multiplied by cosine squared. And of course, we got something we like here, which is the 1. Keep, change, flip. Keep the top fraction as is. Flip the bottom fraction. You get a 1 here. And you simplify cosine squared and cosine squared. Sine squared divided by sine is just sine. And you can only, some of you might say, oh, sine squared, cosine squared, 1. Not correct, because you have to have the plus in between. So sine squared and sine divided by sine is just sine. Just like t squared divided by t is 1 over t. Okay, and I hope this helps. Again, your questions are more than welcome on the remind, and have a good night.